Okay, on Friday we talked about what functions were and how to write a function given a description. And remember, functions are relationships that we can write equations for. So I'm also going to talk about the other ways we can represent functions. So if we are given the function words, in this case the output is 2 more than the input, then on Friday we learned how to write an equation for that. So the output is the same as y, so this is y equals 2 more than the input. So the input is x, 2 more would be plus 2. And we can also make a t-table. So x is on the left, y is on the right. So let's say we plug in -1, 0, and 1. If I plug in a -1 here, -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. You can make your table any length, but we'll stick with just those 3 points. Then I can also take those 3 points and turn them into a mapping diagram. So you have -1, 0, and 1, and you have 1, 2, and 3, and then you connect them. And since this is a function, each number should only have one arrow coming from the left. And then lastly, we also know how to graph these. Okay, since it's a line, we can graph it using slope and y-intercept. If it wasn't a line, you could also use your table. So let's go ahead and use our table. We have -1, 1, 0, 2, and 1, 3. And actually, this point, -1, 1 would be right here. You could have also used your equation. If you start at 2, and you have a slope of 1, you'd be going up 1 over 1, up 1 over 1. Either way, you get this line for your graph. Okay, and you do have graphs to cut and paste into your notes today. Okay, so there's our graph. Okay, so these are all the different ways we can represent one function. The output is 3 times the input, so that's y is equal to 3 times the input is 3 times x. And when they're right next to each other like this, that means multiplication. So you can put the dot in the middle, you can put parentheses, but we know that this means multiplication. All right, so let's make a table. I'm going to choose -1, 0, and 1 again. So -1 times 3 is -3. 0 times 3 is still 0. 1 times 3 is 3. If I make a mapping diagram, I have all my x values on the left, all my y values on the right. And then we already knew this was a function, but we're confirming it's a function because all of these are only used one time. And then our graph. So I'm going to plot our points we just found. We have -1, -3, 0, 0, and 1, 3. You could also have used your equation. Your equation tells you to start at 0 because there's nothing on the end, and then your slope is 3, so you go up 3, right 1, up 3, right 1. Okay, so there's our graph. And again, you have a graph to cut and paste into your notes today. All right, a couple word problems. This one says a car produces 20 pounds of carbon dioxide for every gallon of gasoline burned. Write and graph a function that describes this relationship. Okay, when you are writing functions, your number is typically your slope, but what confirms it's our slope is that it says for every gallon. Okay, so sometimes it'll say for every, for each, or per. All of those words mean that it's your slope because it's going to happen every single time you burn a gallon of gasoline or every single time you do something. So this is going to be y equals 20x. And then x would be gallons of gas because it's 20 pounds of carbon dioxide for every gallon of gas burned. Okay, and that means our output is carbon dioxide. Okay, this depends on how many gallons of gas you burn. So this is an effect of your X. Okay, so usually this first part is your Y, and then it's say for every, and this is your X. Okay, and then it says write and graph a function that describes the relationship. So we wrote our function, and then if I graph it over here, we're going to go ahead and count by 10, so this would be 10, 20, 30, 40, 50, 60, and so on. Okay, we're going to change the scale so that it fits. Then let's still count by ones on our x-axis. So 1, 2, 3, 4, 5, 6, and so on. Okay, so I'm going to start at 0 because I don't have an intercept, so it's like having a plus 0 on the end here. So you start at 0, and then you go up 20 over 1, because that's our slope. So up 20 over 1 would look like that, 20 over 1. All the way. Okay, this one's not going to go completely all the way across because I can't burn negative gallons of gas. It's just going to stay in this positive quadrant. Okay, so if you use 0 gallons of gas, you have 0 pounds of carbon dioxide. Here, if you burn 1 gallon of gas, you have 20 pounds of carbon dioxide. If you burn 2 gallons of gas, 40 pounds of carbon dioxide, and so on. So each point tells you how much carbon dioxide you've produced based on how much gas you've used. All right, so here, let's go ahead and label this too. We have gallons of gas, and over here we have carbon dioxide. Okay. Last one for today. The World Health Organization suggests having 23 healthcare workers for every 10,000 people. How many healthcare workers are needed to meet the World Health Organization suggestion for a population of 250,000 people? Okay, so right here, 23 healthcare workers for every 10,000 people. Okay, that means that Y is going to be our healthcare workers. For every tells us it's our slope, and people is going to be our X. Okay, so you have Y equals 23 for every 10,000 would look like that. People. Okay, so I'm going to go ahead and type that into my calculator and get a decimal. So 23 divided by 10,000 is written like so. And then X stands for people, the amount of population you have. And Y is going to be the healthcare workers that you need. Okay, because this was on the top of our slope, this is on the bottom of our slope. Okay, and then let's make sure we answer the question. How many healthcare workers are needed for a population of 250,000 people? Now, we just talked about how people stands for X, so we have to plug this in for X. Okay, so right now we would have 23 10,000ths, 23 10,000ths times 250,000. So let's do that. We get 575 healthcare workers. Okay, it's important that when we do word problems, we label so we understand what's really happening. So that's why I'm going through and labeling as I go so that we can make sense of what numbers go where. Okay, at this point, you can raise your hand and show me your notes to get your homework.